Okay, so in this lab here, we're going to be taking down some temperature time data to analyze what's referred to as a cooling curve and a melting curve. The chemical that we're working with here is stearic acid. It's already been sitting inside this boiling water for a little bit. What we want to do is we want to actually liquefy it at first. We're going to analyze the cooling curve first, and then putting it back into a hot water bath, we can analyze the cooling curve afterwards. So how we're going to set this up here is I'm going to take the stearic acid from the boiling water. It's already inside these test tubes here. I'm going to be placing it in this beaker here just as a nice stand. I'm going to lower this burette stand here so the thermometer can equilibrate to the temperature of stearic acid. When it starts to cool down, I'm going to start my stopwatch, and I'm going to be reading out to you the temperatures in 5-second intervals. I want you to note down these temperatures here so that we can actually plot this as a graph later on. So I'm just going to pull the stearic acid. Right now here it's a liquid. I'll give you a chance to see it beforehand. Okay, I'm going to just prop it into this stand here. Okay, make sure it's standing up as much as I can there. I'm going to lower my burette stand so that my thermometer can sit nicely inside the stearic acid. We're going to give it a while for the thermometer to actually equilibrate to the temperature of the stearic acid before we start taking down some readings. Hopefully you can still see the stopwatch there. So when it looks like it's hit the maximum temperature here, I'm going to start the stopwatch, and then 5-second intervals I'll tell you the temperature. So. Alright, looks like it's pretty steady here. I'm going to start my stopwatch. Starting temperature here is 77.8 degrees. Still at 77.8 degrees. 77.8 degrees. 77.5 degrees, 77.5 degrees, 77.5 degrees, 77.2 degrees, 77.0 degrees, 77.0 degrees, 76.5 degrees, 76.5 degrees, 75.0 degrees, 75.0 degrees, 74.3 degrees, 73.9 degrees, 73.9 degrees, 73.5 degrees, 72.8 degrees, 72.5 degrees, 72.0 degrees, 71.0 degrees, 70.8 degrees, 70.8 degrees, 70 degrees, 70 degrees, 69.5 degrees, 69 degrees, 68.6 degrees, 68.0 degrees, 67.5 degrees, 66.8 degrees, 66.5 degrees, 65.9 degrees, 65.5 degrees, 65.1 degree, 64.9 degrees, 64.5 degrees, 64 degrees, 64 degrees, 63.5 degrees, 63.5 degrees, 62.5 degrees, 62.5 degrees, 62.5 degrees, 61 degrees, 60 degrees, 60 degrees, 60 degrees, 60, 60 degrees, 59.8, 59.8, 59.5, 59, 58.8, 58.5, 58, 57.8, 57.8, 57, 56.5, 56.5, 55.8, 55.5, 55.5, 55.2, 55, 55, 55, 54.8, 54.8, 54.8, 54, 54, 54, 54, 53.8, 53.8, 53.8, 53.5, 53.5, 53.5, 53.5, 53.5, 53.5, 53.5, 53.5, 53.5, 53.5, 53.5, and 53.5. Alright, so I'm noticing that the stearic acid here has started to solidify here. You can actually start seeing it qualitatively here inside the test tube. The temperature here is still 53.5 here. Again, there's nothing magical about us going in 5-second intervals. I just wanted to give you some detail as it started cooling down here. We're going to eventually be plotting temperature on the vertical axis, time on the horizontal axis, and that way you can plot a melting point curve. Hopefully where the temperature actually steadies out is actually the freezing point for stearic acid. You can make a comparison to the literature value and see how we did. Just for reference, we're still at 53.5. And one last reading here. 53.5. Thanks, guys. Okay, so we're going to do part 2 of this experiment here, which involves a melting point curve. I'm just going to show you what the stearic acid looks like at the moment. Remember, it had been solidified inside this solid here. I don't want to be pulling out the thermometer at this moment here for risk of damaging the thermometer. Notice that our starting temperature is still roughly about 51, 52 degrees or so. I have sitting in front of me here a hot water bath. We do have a second thermometer here just to read the temperature of the hot water bath here. It just needs to be hotter than this one here so it can actually melt the stearic acid. What I'm going to try to do here is I'm going to try to prop this into our burette, just like we did before. And then again, we're going to start our stopwatch here. Because of the hot water bath here, it's going to start melting the stearic acid fairly quickly. And hopefully I'm going to orient it in such a way that you can see the time and you can see the temperature directly. I'll still try to read you the temperatures if I can, but it's much better if you can actually take a look for yourself. So I'm just going to just prop it in the back here just to get set up. Okay. So again, in a second here, I'm just going to drop this here into the hot water bath here. I'm going to try to clamp it onto this burette clamp, and then we're going to start the stopwatch. So let's just give that a go. So starting a stopwatch here. Okay, so first reading here, 51 degrees. 51 degrees. 51.5 degrees, 52 degrees, 52 degrees, 52.8 degrees, 54 degrees, 54.5 degrees, 55.5, 56, 57, 57.5, 59, 60, 60.5 degrees, 60.5 degrees, 63 degrees, 64 degrees, 65 degrees, 68 degrees, 69 degrees, 70 degrees, 71 degree, 72.5 degrees, 73 degrees, 74.5 degrees, 76 degrees, 77 degrees, 78 degrees, 78.5 degrees, 80 degrees, 81.5 degrees, 82 degrees, 82 degrees, 83 degrees, 83 degrees, 83.5 degrees, 84.2 degrees, 84.5 degrees, 85 degrees, 85 degrees, 85 degrees, 85.2 degrees, 86 degrees, 86 degrees, 86 degrees, 86 degrees, 86 degrees, 86 degrees, 86.5 degrees, 86.5, 86.5, 86.5, and 86.5. All right. So again, we'll make some qualitative observations here. Definitely we can tell that the stearic acid here has been liquefied here in the test tube. I have the two thermometers. This thermometer here is sampling the temperature of stearic acid. My hot water bath right now here has been a pretty constant 85, 86 degrees or so, which is why it's very hard for us to get even hotter than that. But fortunately for us here, it's already been liquefied here. I do want you to plot that temperature versus time. So temperature on the vertical, time on the horizontal, and then hopefully where the temperature steadies out here would be corresponding to the melting point for this chemical. Thanks, guys.